Okay, in the last video there is some voice issue. Lot of people commented that. I have to keep that thing in mind. Hopefully this will be alright. So in the last video we saw that the Newton's laws are violated. So if we write the equation for S frame, the net force on the charged particle is 0. There is no magnetic field. There is magnetic field, sorry, but there is no electric field. As there is no velocity, the net force on the charged particle is 0. But from S prime frame there is some force, and velocity and magnetic field are perpendicular to each other, so we are writing QVB. So there is some force from S prime frame. Okay, let's move forward. So these are the four sets of Maxwell equation. We all know about it. These two equations are the equation containing the source term, and these two equations are the equation containing no source term. This is the divergence of E is rho by epsilon naught, and this is curl of B equals to mu naught J mu naught epsilon naught dE dt. Epsilon naught dE dt is the famous displacement current invented by Maxwell. So mind it, these four equations are in free space. So in a source free region there will be no charge, no current. So they will become divergence of E 0, curl of B will be mu naught epsilon naught dE dt. There is no J, source free. So and divergence of B is always 0, and curl of E is minus dV dt. So from equation A we are taking a curl of that equation. So it will be look like curl of V equals to mu naught epsilon naught curl of dE dt. So I'm expanding the left hand side. Okay, we can expand it using vector analysis, using something like the back minus cap. I'm not doing it. I'm using the tensor analysis, which is much more elegant and you don't have to remember anything. So step by step, curl of B will be epsilon ijk del j curl of the index k. Again expanding it, epsilon k lm del l bm. Now using the Kronecker deltas we are expanding this. This will be epsilon ijk epsilon k lm. It will become del of il del of jm del of im del of jl and del j del l bm. Now we are again expanding it. Now see, j are contracting here, and here j is contracting, so it will become del il del m del l bm minus del im del l bm. And here I L and L are contracting again, and it will be delta I del m bm minus del l bi. Now this is divergence of B. It will be always 0, and this is Laplacian of B. So it will finally get minus del square B.